If you've watched enough science fiction, you know that food is still a requirement in our human future. Now, obviously, when you have things like Star Trek where they have a replicator, then you just make whatever you want, and that's, it's magic. But there are some shows that try to tackle this realistically. Think about The Martian, where he is making growing potatoes in regolith with poop, or think about the Ganymede station in The Expanse, where they're growing food in greenhouses. What does the future of food in space realistically look like? What are the requirements? What are some of the sort of hidden showstoppers that perhaps you're not thinking about when we think about the future of humanity eating a healthy food in space? Food is such a big part of how we live our daily lives. It is our sustenance, but it is also a source of happiness, and that one of those creature comforts that we're going to require if we're going to want to live and work, maybe permanently, in space. My guest today is Tor Blomqvist. He's an agronomist and PhD candidate at the German Aerospace Center. He and his colleagues recently wrote the first paper in what is going to be an ongoing series into the future of food production in space. What are the current methodologies that they use now, and what will things move towards in the future when you consider some of the sort of unique requirements of space? And there are a lot of gotchas. I mean, there is the radiation, which is going to take a lot of the kinds of greenhouses that you imagine right off the table. But there are some food safety concerns that are going to be pretty hard to get away from. And we have literally no research into this at all. And so there's a lot of challenges for us to be able to get to that future of being able to just like eat a salad on the moon that Tor's been thinking about. All right, so enjoy this interview. Tor, I'm sure you've seen as much science fiction as I have, especially as it relates to people growing things in space and trying to live off the land in space. Does anybody do this well, do you think? I mean, we've seen poop potatoes in The Martian. We've seen sort of in Ganymede in The Expanse. Who does a good job of recreating what the future of space food might look like?
I actually don't know, because this future of space food is still so uncertain. But I would say that a lot of people have the various different ideas of what space food is and could be as normal with food in general, actually. And I think the best kind of depictions of that is the most real ones. So I would say, actually, like, if you go really, really, really far into the future, The Expanse might actually be onto something, because they're actually growing real food. Then you've seen the people with the pills and the stuff, and this is the things that that's the things that we know are not going to work. But one thing that actually comes back, if you don't look at like what solutions they have for food, is actually how often they talk about food. So even in sci-fi movies and in general, you always talk about food. It's something that is close to us. We think about it all the time. Even if we don't like to cook it, we always think about food. It's just a part of us, and it's such a deep-rooted cultural and emotional thing. So
Yeah.
it's
But I mean, I think that when you look at the unique constraints of, say, weightlessness, or, there was a paper that I read that crushed me for the better part of a couple of months, where they were talking about the amount of UV radiation and cosmic radiation and solar radiation that would be coming through a greenhouse on Mars, and it would kill the plants.
yes.
Right? So you can't have a greenhouse on Mars or Ganymede or whatever. That suddenly this whole idea, I just watched For All Mankind, and they had a greenhouse where they were growing corn, and you're just like, nope, you don't get that. Right?
Yeah. But it's almost true. Like we still, plants can withstand a whole lot more radiation than humans can, and they actually, in fact, like a little bit more. But it's one of these first research questions that we actually have to ask ourselves before we attempt doing anything. Is like, how much, like, can plants actually survive in, like, outside of the Van belt in deep space radiation? We have no clue, and this is something that we really, really need to test before we start even talking about implementing larger scale systems. So yeah, you're definitely onto something there.
Yeah, I mean, the Chinese they grew a couple of little seeds on the
Mm,
moon in one of their missions, and that's like as far as we've gone at this point.
right. So we need to essentially everything we did in low Earth orbit, we need to redo again on the lunar surface. So like, can yeast survive? How does it affect them? Can, plant cells survive and how does it affect them? Can plants grow and so on? And then, you come to the hazards and these kind of things that are associated with everything as well. So there's so many questions to answer. So we need access to the moon as fast as possible, essentially.
Right. Yeah. Okay, great. You recently wrote a paper sort of synthesizing a lot of what we've learned so far and then trying to make some predictions about the kind of research that needs to be done for us to be able to get better answers if we do want to live in space for longer periods of time. So, what were you kind of looking to answer with your research?
So that research paper that you read is the first of a series that is actually about to come. And what that one did is essentially define the system boundary. So it's about that the problem lies in that a lot of people look into production only. So they're like, can we grow plants? And can we grow something else? But they never really, they kind of judge the implementation based on if they can actually grow these plants or not. And another problem is that a lot of people focus on something called bioregenerative life support systems, which is essentially if you take physiochemical life support systems, exchange them into biology, essentially how the ecosystem on Earth works. Plants produce oxygen, sequester carbon, and so on. And that focus sadly goes into like what can produce the most oxygen. So it's no longer about food. So essentially, what I wanted to emphasize was that if we're talking about having some kind of hybrid food system with prepackaged and produced food, or if we're going towards an autonomous food system, regardless of the scales that we're thinking about, so the same rules, we have to think of it from an actual food systems perspective. So that would be not just caring for the primary production function, but also all of the downstream functions that comes with that, the interactions in between them, and also some of the human elements that actually kind of help shape how this system actually looks like. Essentially, arguing that whenever we design our like ground test demonstrators, for instance, instead of just being purely plant test beds, they should have a full system mindset to implement and integrate everything that we can in there to see essentially what emergent properties may arise from it, how we can design for robustness and ultimately the attributes of resilience. Uh, to kind of frame the system boundary regardless of the scale of the system itself.
Yeah, I mean, so give me a sense though. Like you've got four Martian explorers
Mm,
on the first permanently inhabited base on Mars. They're setting up to eat their meal. And how do you sort of, you're talking about these sort of like constraints and boundaries and
right.
downstream and blah blah blah, like what is making up their meal?
So, in let's say, point out if they would not live out of prepackaged food, because I still think if it's for astronauts, they're most likely going to have larger, in reality, like a large like amount of their food is going to be prepackaged from Earth.
Right.
But let's say for fun that it's not going to be, and they're going to start like implementing food production. So the majority would be plants. It's the most ready kind of thing that we have. We have done most experiments on plants, and it's also the most acceptable to us. They contain a lot of micronutrients, like ready-to-eat crops. So it's all that we have. They have freshness, variation, and so on. So it's essentially the most acceptable thing that we humans can eat. If you start to implement like algae bioreactors and force feed people with algae mush, you're gonna have starving astronauts. They're gonna die after 3 days because like they don't want to eat that. Like go and try duckweed. Like it's so stupid. It's not food. So essentially, just because it contains nutrients doesn't make it food, right? So they need to have, and then depends, like, are they going to be autonomous or not? So are these four astronauts going to have a whole autonomous food system? That means that they will all four astronauts work total overtime, I guess, and not essentially have time for any of the exploration tasks that they're there to do in the first place. But if they would, I mean, they would have to grow staple crops as well. They would have to get a fat source from somewhere. And as soon as you start implementing these kind of things, you start looking at more and more downstream functions that you need to have. So you need to be able to process these crops. Actually, even ready-to-eat crops would have a processing step, like you have cutting, you have washing, you have maybe non-thermal sterilization where you sanitize the crops. You have storage that you need to implement. There's a whole lot of infrastructure actually. And then you need to grow enough variety for people not to get bored by it. I mean, if you say your favorite food, like you can't eat that for the whole week. I love lasagna, but I made so much of it on Monday and I'm already tired of it. Like, so we need variety. It's like any human being essentially. And then especially if you're up in space, I mean, could you imagine, like, it's not like you're gonna have that much inspiration or like influence from the outside environment that could kind of satisfy you. Like we have trees to look at, plants, and different things, human beings, and there's a lot of impressions from everywhere. But if you're in a dark and desolated place, that must be a lot harder. So that comes from food essentially.
Right. So you sort of see like say we've got these four astronauts, they've arrived, they brought a whole bunch of prepackaged food that's probably going to supply the vast majority of their calories. It's going to have the lasagna, and if they get bored of that, then eat the burrito, and they'll have enough prepackaged food that is shelf stable and can withstand the duration of say, I mean, it's going to be like a 2-year mission, and like do we even know the answer to that question, that you can make shelf stable food that can withstand that radiation environment and not
exactly
totally lose its nutrients over the course of that.
So that's
duration.
the problem with prepackaged food, is that it's not shelf stable forever. And I think currently it's just like 1.5 years or something like that. And a Martian mission, as you say, it's 3 years. We're looking at 3 years. And for there and back. So the idea also, because there's a lot of food, I think it's like roughly like 2.4 kilos per person per day. So it's like ends up in like 10, 12 metric tons of food. So the idea that NASA has of that plan is to launch it ahead of time, and that requires a 5-year shelf life. So it's just like one of their plans that have put that requirements on it, and you need to have. Even if you find like one food that can have a shelf life of 5 years, you still need to find about 534 others. So yeah, there's it's sad because there's a small group of people working on at NASA with the prepackaged food, and I can't imagine like how much they have to do, and they need help in general just to improve packaging and all that kind of fun stuff. But in order to kind of add some inherent redundancy to the food system, but also kind of plan for these upcoming long duration missions to the moon and Mars, we are looking into how we can actually produce food.
Right. And that was sort of the second part of this, I think, is that then they're going to set up some kind of greenhouse. And we talked about this earlier on, you're probably aren't going to have the greenhouse that you imagine. So you're going to have something more like what they have in Antarctica. And I think, can you explain the system that's in Antarctica right now, run by the European Space Agency?
So it's not run by the European Space Agency. So I think you're referring to Eden ISS, right?
Yeah, there's a facility. I don't know. Maybe ESA is producing press releases from it, because I've been reporting on the largest tomato yield in this facility in Antarctica. So things like that. So
yeah, so
it's
you
like
might
a
be
sea can filled with LED lights and hydroponics.
So you might refer to, I mean, I think like ESA is also like stationed at the French station. I can't remember. But you might be referring to what we have been busy with at DLR for the past, like since 2015 or something. Was the Eden ISS plant production module. So that was outside of Neumayer Station, so the German Antarctic station. And it was stationed there for about 5 years or something like that. So it's essentially a large container that is completely closed off to the outside environment and works as so it's not a greenhouse. A greenhouse is glass essentially. So like if you think about the greenhouse effect, it's that's what you're referring to. But this is controlled environmental agriculture. So using lights and nutrient solutions in order to for the plants to grow hydroponically. So essentially, you either spray the roots or you dip the roots in a nutrient solution called fertigation, and then you use LED lights to for them to grow. And we tested this for successfully in Antarctica for about 5 years, and it was actually it's not the environment that you could think would be the major hurdle, but it's isolation. Like Antarctica is crazy. You have a window of about a month or so when you can actually go there, and, and then it's still not sure because like they don't have airports, so the planes are flying, and then they might need to turn back because of cloudy weather or something like that. And then you have boats that also like just come once a year with supplies and a few people, and then a few people stay for like a month, and then the rest go back. And the overwinters are there for 14 months. It's like 10 of them. So there were a lot of good experiments regarding not only like plant growth, but also like the human factor behind it, how it is to actually eat fresh food all of a sudden, and how that affected people psychologically, nutritionally, and many many other things. But also, from a hardware perspective too, like it's not like we can run down to the hardware store because it's quite far. There is none. So if you're like, if something happens, you're screwed. Like you. So that's also the mental thing that people in Antarctica get is that like that sense of solitude that if something happens, I'm dead. And that's something that I can never understand because I've never been there. I can just kind of try to comprehend what it feels like, but that makes it such a good analog place for this.
It does feel like almost your job, previous to doing this job for the German Space Agency, you were a chef.
Yeah.
And your job is to sort of give people happiness beyond sustenance. Like sustenance, you can just eat the duckweed, but to actually deliver them happiness, you're actually coming up with meals, you're designing things that you hope are going to make them improve their lives. And that really, I watch television shows like Alone, which is actually set on my island, Vancouver Island, where people go and they spend several months by themselves trying to sort of withstand it. They go crazy because they're alone and they require human and they're having to find their food and they're eating limpets off of the beach and stuff, and they go bananas. And that we need to deliver those human comforts, and one of those is going to be food. That sort of the secret to a happy astronaut is going to be through their stomach. I think I wouldn't be surprised.
Yeah. No, but it is. I mean, we can already see it on the ISS. Like, it started even like back in the days when they started to have these tubes and cubes of space food, right? Astronauts wouldn't eat it because it was simply just too boring. It didn't taste anything like it. So the space food had to develop, and it developed a lot. And even now, kind of resembles like ordinary food. It's just like there's still a problem with variety and the taste of the food, and the fact that like I've heard also that half of their food nowadays are like military rations, and and it's that is not good food. And so like they don't eat it, so they come back malnourished, and this is what happens. But also, I mean, if you want to, an interesting part too is that food, we like food for so many reasons, but if you want to get an actual physiological reason of why we need to eat good food too, is that the smell that we have and the taste, it works like a priming process. So when you smell something good, you start to salivate, and your whole metabolic system starts to get activated. And if you look at something that's completely utterly disgusting, your body's not going to accept it. So these processes don't start necessarily, so you don't actually properly process the food. So it's we need that for that reason as well. But food is it's social, it's emotional, it's cultural, it's extremely important for for us as human beings for all of those reasons.
And so when I think about sort of what they're doing in Antarctica, you're essentially getting a fresh salad. You're getting greens, mustards, maybe tomato. Like I'm not sure how far they were able, how complicated food they were able to make in the greenhouse. How interesting a meal could you make with what you pull out of the greenhouse?
So,
and when I say greenhouse, is that a right name? Do you call it a green? You call it grow facility?
So I call it plant production module because the greenhouse is technically with glass windows. But
yeah, no, I know, but it's such a terrible name. Plant production module.
It's hard, but it's a controlled environmental agriculture, or CA, or you could call it plant production facility or something like that. I don't know.
Yeah, I don't like that. We need a better name. I'm calling it the greenhouse, even though there is no glass.
Yeah, but it's so many people calling it greenhouse, even though it's wrong. But it's so you're not the only one. And so yeah, I mean, like we grew quite a lot, or I wasn't there, but my team grew quite a lot of things actually. And it was not only lettuce, it was herbs, it was tomatoes, it was cucumbers, it was even like kohlrabi, it was a lot of crucifers, radishes, you name it, like a lot of green stuff. So you could produce a lot of interesting salads from it. So there was a whole lot of variety. Then the problem was to take care of it and not let it go bad. And so it depends of the structure you have of your food supply too, like how much you need. And this is something that I'm trying to bring up as well, is like, how far do we want to take this? Like, do we want to have a fully autonomous food system where you can satisfy like 100% of your diet? Or do we rely on half of it being prepackaged and just like add the greens for some freshness and variability? And that's an unanswered question that we have too. It depends on so many factors.
I mean, I've got to assume that there's a balance. Like if you take protein and carbohydrates, then you can use what you grow in the greenhouse, the controlled plant facility, the plant complex, the plant matrix. Anyway, that you can make it tasty.
Yeah.
Right. And so you're not looking to derive calories from your grow place. You are just trying to improve mental fitness, mental health.
Yeah, exactly. That way. It's extremely important. And also, I mean, the like those kind of plants are easier to grow too. They satisfy the micronutrients, and those are the first ones to go in space or in long term. Because if you think about it, antioxidants, what do? Well, they do protect your body from oxidation and the plant's nutrients themselves. So we need those, and they are also the first to go when they get oxidized by radiation. So if we can produce those, that's a big thing.
So I want to think about like methodologies. In Antarctica, you have no access to soil. You are, as you said, you're either doing it hydroponically or you are spraying the roots, which is, I've gone down a whole YouTube rabbit hole just on this, that you can build these like little sprayers and you put your plants on it. It's very cool.
You can do it easily at home, actually. It's super simple.
But comes with the risks of its own. The sprayer stopped working for 1 second and then your plant roots dry out and then the plant is dead. So there's it introduces a ton of risk. You get any disease vectors into your system and you are spreading them at rapid speed across all of your plants. So what about the regolith? Can you grow things in the regolith?
There's been a mutual understanding from the whole space world, essentially, that we are not going to waste any research money on regolith. And it is simply like, we don't need it. We have hydroponics or aeroponics or any type of that. And it works. It functions very easily and flawlessly. Regolith contains a lot of heavy metals, corrosive stuff that you will never, ever want near your food. It's one of the, like, NASA spends so much money keeping regolith outside of the habitats. So, like, we're never going to bring them inside. So we don't need it. And honestly, if we want soil, it's much easier to create soil because we're going to produce so much inedible, plant mass. So that we also need to kind of recycle in some way or throw away or something. There's a whole lot of problems coming with the recirculation of nutrients. But you might have, and if you need soil, you might as well plan on actually creating soil. But regolith is never going to be close to food. That would be
Huh,
one of the biggest
interesting.
hazards. Yeah.
And
Um,
so would it be like essentially if you did want to go the soil route, you'd be growing in pure compost?
Pretty much, yeah.
Yeah.
Yeah, exactly. Or you
That's interesting.
transport up peat or something. But yeah, you could actually do it from compost, but you don't need soil. And if you want soil or need it, I mean, you're also going to introduce new food safety hazards and start poking at regulations in space that we have never thought about before. But it is much easier and better probably to do it from the inedible plant matter and from the like fertilizer that you produce yourself, and so on. So
Well, that's interesting to me though, that I mean, from the nutrient standpoint, you're essentially delivering the nutrients in bags from Earth, right?
mm,
And then that is going to be perfectly shelf stable. And then when you're ready to plant, you add whatever, you titrate in the right amount of whatever the nutrients are, and then that gets sprayed on the plant roots, and then that grows the plants, and then the plants grow. You are pulling carbon dioxide from the Martian atmosphere, I'm assuming, harvesting the plants, and you're building up this recycling. Do you think you could decrease, like, do you think through recycling it could be less reliant on sending those bags of nutrients from Earth
yeah. So
eventually?
this is also a research question that is current, and I might add we're most likely not going to use the Martian atmosphere for anything. It's all going to be closed, and we produce carbon dioxide ourselves. But so this we actually need to collect that carbon dioxide as well, and because the plants also need much more of it.
Right. So
But
it's actually like a
anyways,
waste gas. You kind of need
yeah,
to minimize the amount of
exactly.
carbon
We need to
dioxide you have.
circulate the
Yeah.
carbon dioxide as well. So and also, like, as soon as you harvest those plants, they actually start to produce carbon dioxide and consume oxygen. So it goes the opposite direction when you remove them from the um, but no, anyways, what you were asking essentially is like how can we improve the circulation of the resources that we have, and maybe reintroduce the nutrients again into the plant production. And we can, and this is also a trade-off that we have to look at, because you need a whole lot of hardware and processes to actually be able to recirculate these nutrients back into the hydroponic system. Because also what you want is essentially the nutrients in its elemental form, and because that's what the plants take up. So this is also why if you use like organic fertilizer, it's going to take some time for it to break down into its elemental form before the plants can actually utilize it. But anyways, that takes up a whole lot of processes. They're also not necessarily food safe, and this is also a big question mark terrestrially at places as well. Um, and in space, we have yet to have standards and regulations for these kind of things. Right now, it's just like any microbe, any good microbe is a dead microbe. Like, you can't have anything. So, as the current regulations are, we can't have food production in space. So this is also something that we need to go through and look at and change. How is a very good question, but it's something that we are also trying to see how we can do essentially. A better route might actually be to just like incinerate it. Like, you have a bunch of inedible plant material, and then you just put it in an incinerator. You get nitrogen gas and carbon dioxide and some minerals, and that might be the easier route.
Yeah, I know you can buy, like, for your kitchen, you can buy like a little incinerator for your food scraps that, for me, I have lots of property. I can just pile my food scraps up in a pile and then come back a year later and I've got compost that I can put on the garden. But I think with the astronauts, I mean, you're looking at the poop potatoes
Hmm.
as well, and there is no more efficient way to transfer human diseases than by spreading waste on plants and then
Yes,
letting them
exactly.
grow and incorporate them. So you've, both the human waste and the plant, all of that has got to go through some kind of incineration process to sterilize it before you then can reintroduce it as a way of growing your
Exactly.
plants.
Or like a biological process. Like for instance, you can create biogas and you can use the digest that you get from it, which is a pretty good
Right.
fertilizer. But then you need to also convert that into something that you can put in hydroponically. So this is also an argument too for like maybe like that we could produce soil or something like that. For sure. I'm not on either side of the argument, but it's just
Right. But even if you can come up with the powder that you are then reintroducing through your aquaponic system,
yeah,
right, hydroponic system
hydroponic
into
system.
your hydroponic
Mhm.
system into the plants, then that's, then you can cut back by 50% or 75% the
Exactly.
bags of fertilizer that are being sent
Yeah.
from
The
Earth.
problem is that the more circular you want to become, the more hardware you have to launch. Because also eventually, if you're looking at like a fully circular system, it's gonna be so much stuff that you need and so much processes. So eventually, you stand there with all of these different systems, and even have like most likely even like an aquaponic system with fish, and because that would be very efficient, and like oysters and stuff that really like filters water and so on. That would be really cool, but it like then you have a food system that requires like at least 10, 15 full-time workers, and it's then you're starting to get away from the reason why you're there from the start. So that becomes a problem again. So
But it's interesting to me because I think that's people's instinctual idea for how this must go. You talk
mhm.
about the people who are like, oh, we really want to build a city on Mars. That chain of 15 machines, 15, people and their machines, each one performs a very specific function. This one collects the material, this one renders it, this one turns it into the powder, this one mixes the powder in with the fluids at the right quantity, this one harvests, blah, 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 right? That is so either you have shelf-stable food in giant bags that arrive and it is simple, dead simple. You cut a bag open, you eat it, you throw the waste away, right? Done. And then on the flip side is that you're trying to live as much as possible in this closed circle environment. And yet that is what must be done for long-term, fully sustainable habitability on a planet like Mars or a place like the moon.
Yeah,
And
exactly.
finding that balance point in between.
And then we also have there's another uncertainty, which is essentially how do rockets develop during this time? Because we're not going to have a fully, like people like long duration missions on Mars for a while. So in that time, will we get like nuclear powered rockets that can get there a lot faster? So if we do, what is it to say that we are not gonna do our exploration outposts on Mars similar to that we do on Antarctica, where once a year they come with a bunch of frozen foods, and then we have a plant production facility, and then they just send the trash back, and that could be a possibility too. We have no idea.
Yeah,
Yeah.
I can't imagine them sending the trash back. Like I can imagine them piling the trash up very carefully into separated heaps that will then some future group will go, now we're going to dig into the giant pile of astronaut poop that's sitting there. But I can't imagine them wanting to send that poop back to Earth.
Yeah. I
Except
think it
for maybe
depends on
for
how the
scientific
regulations
purposes.
look like, because I don't think you
Yeah,
can
totally.
pollute space, so I don't think you can just throw something out.
Yeah, I'm sure they'll. I mean, there are bags of poop on the moon, so it's been done.
You're right.
So then, based on your research so far, where would you, if you were put in charge and you were trying to figure out how to direct our research to make future exploration a more humane process where people can eat food that they enjoy and striking that balance? Because we sort of really talked about this is all give and take. It's all about balances. Where do you think that we know the least about that we should really progress our research?
So I'm going to give you half long answer. So this is something that we've been thinking about a lot, and I also discovered this. So about 2 years ago, I got invited to be a judge for the NASA Deep Space Food Challenge, and I started talking more with the team behind that and all of the people over there. And we also decided that there is not people don't necessarily have an idea of where this would be implemented or when this would be implemented. Some people have ideas that are so far off in the future, it's just not feasible at all. And some people are very confused behind, like, is it moon or low Earth orbit, and so on. So we and some people have these like really also like strange ideas where they just are so buried deep in their own little silo. And so we were saying like, hey, we need to create an organization that kind of brings together the whole, global sphere of space food people, and that will help us also create this like common strategic objective essentially. So it did, and it's been very successful, called the Deep Space Food Consortium. And right now we're also in the process of actually starting the to actually write a roadmap, because there is no roadmap, and the roadmaps just exist from the agencies. So the problem with the agencies that exist is essentially some of these roadmaps are essentially them trying to motivate their own research, why it should be funded, so there's not a truly independent roadmap that is purely based on like what do we need and when do we need it. And that roadmap also needs to be developed together with the terrestrial industry, because we can't succeed without their knowledge. There's so much knowledge of both like implementation and literally anything food wise from the terrestrial agri-food sector. And if we can also align with them and create joint research agendas with the terrestrial sector, then we can also better create these spin-offs and provide provide value to the things that we do terrestrially. And so this is something that we really, really have to do together with them, actually. But to go back to space, then what we need to essentially is we need to start doing research on the lunar surface pretty much immediately. And you can think of this as in like different phases. So say that phase 1 is the fundamental research phase. This is when we do all of the fundamental research, like do plants actually, like do yeast cells grow here? How is it to grow plants and so on? And we create readiness levels accordingly. And then you have an applied research phase where you start to test more, like kind of like the current system on the ISS, where they grow plants in the veggie system. And then you start having like an early demonstration phase where you kind of like demonstrate technologies, go, and not only from then you can go over to like early production and kind of continue from there to see where you are. And then the most missing things that we need actually before we can go to demonstration essentially is food safety. Like we have no way to monitor and verify food safety. So even now when they grow plants on the space station, they have to kind of like send them back to Earth to test them before they can get confirmation that they can eat them. And even then, they sanitize it between pros and wipes. So like each leaf goes behind like between a wipe and a little baggie. And that's not sustainable. Like
No, I
you
can
can't
imagine
do that
that's
with a whole.
tough.
Yeah, exactly. You're gonna do
Make a
that with
salad.
like 1,000 plants. Good luck. So
Yeah.
yeah, and so these are the things that we really, really need to solve. And from there too, we need to change the whole like standards and regulations format for it, because I mean, as you know, like the current space regulations are not made for food production, and they're written for the prepackaged food. And so we need to look into that. We need to come up with a whole new space standard essentially for it.
Yeah, it's
So
it's interesting. I mean, you think about things like E. coli. The problem is we, the humans, are bringing that stuff with us.
mhm.
That you can't get rid of the E. coli. It's there on our human bodies all the time, and it's just looking for the right environment
Right,
on
right.
the on the station. Same with botulism, all this kind of stuff, right? Like all of this stuff is coming along for the ride. And then the question is, will we make the right environment for it to thrive?
I mean, the space environment is that's also like a fun thing, right? Like you have this essentially like on the space station, like microgravity environment where they also produce faster or and
oh, interesting.
Yeah, and it's humid, and you don't necessarily get like the water away from the leaves properly and everywhere.
Yeah, it's
and
the perfect temperature. It's
exactly. It's the perfect environment. So, but you have also like there was a paper that came out recently about the whole microbiome of the ISS that is quite interesting.
I've reported on a couple of these
far from sterile.
Yes, that is far from sterile is a great way to describe it. That it is kind of like a moldy locker room.
Yeah, exactly.
Yeah. And so it's interesting though. I mean, the way what you're sort of identifying is it feels like it's sort of similar to this idea of like long-term habitation in space. People like Elon Musk, we want to build a city on Mars. And you say, okay, fine. Can the human body survive on Mars for longer than about 2 years? And the answer is, we have no idea.
Yeah,
we have no idea. And, can the human body gestate? Can you actually, is it like a crime against humanity to have a baby on Mars? We have no idea.
Mm-hmm.
So, and it sounds to me like from your perspective, same thing with plants, like, will they even work outside of the right out of is the amount of like, because you can build a sea can on and build on the surface of the moon, but it's still going to get bombarded with cosmic rays. So and will the cosmic rays kill it? And so are you going to have to put a meter of regolith between your growing can and space itself? That's an engineering challenge on top of it, right?
That becomes an architectural issue, and that's also like being discussed as well. So this is also why we always have to work together. Like the whole thing about compartmentalization, it's so stupid. We have to we have to bridge all of these silos and really just like work together, everyone. And the same thing, like I'm gonna publish a paper soon too on essentially the interfaces between the food production system and ECLS, like how all of the things that the food system actually produces, from just VOCs to just increased humidity, power, heat, and also how essentially all of the bacterial hazards become like airborne bacterial hazards and wastewater and so many things. Can list forever.
What is you were one of the judges on the Space Food Challenge. So what is the best space food that you think has been designed so far? What's the meal that you're like, I could eat this even at home?
Oh, you mean from like prepackaged food, or?
I mean, a meal that has been designed for astronauts to eat that you think is genuinely delicious.
So, I mean, I have never tried the astronaut food that the astronauts eat, the prepackaged stuff. And the Space Food Challenge was actually not on prepackaged, so it was more in production. And even though I think like the prepackaged people also need their own little challenge, especially like packaging material and stuff. But from a production perspective, I mean, it's like plants, and anything you can make like kind of normal is good. And I mean, they had relatively normal food on the ISS too, and they make their own little weird combinations as well.
Yeah,
that I wouldn't.
Yeah, I remember there was a video from Chris Hadfield making a burrito on the station.
Yeah, because you can't have crumbs, so you can't necessarily have normal bread. So tortillas are the go-to. And then there's a whole lot of literature also like describing food fights and so on. That sounds so fun. It's throwing food at each other
in zero gravity. Yeah, it sounds and then you're just contributing to the
tortilla frisbees. I mean, I would be perfect astronauts. That's the only thing I would do.
Tor, what are you obsessed with right now?
Right now, I'm obsessed with. Outside from work, I mean, as normal, I'm always obsessed with food and drinking good wine. But I recently have become obsessed with split boarding.
Split boarding. What is
Yes,
that?
it's a snowboard that you split so that you can tour up. So you take the bindings and you split the board, and then you attach them like skis, and then you have skins underneath, and you walk up the mountain. I've been
Right.
snowshoeing my whole life, and I don't know why I haven't bought a split board. So I'm like obsessive over it and like researching that every day instead of working.
Okay, hold on a second. I live on a mountain. It's snowy in the wintertime.
Hmm.
And I've got some snowshoes and cross country skis, but now I'm in tree. I've done snowboarding in the past. So you have separate skis, or like separate two little snowboards, which
Yeah.
sounds like skis to me, but I'm assuming they're different than
I mean,
skis.
take a snowboard and saw it in half,
Yeah.
lengthwise, and
Yeah.
yeah, then you can split it. So you have little connectors that connects the board so that it's attached, and that's the whole snowboard when you go down. But then
Right. And
you
do you change the
detach it.
orientation of the bindings then?
Yes, exactly. So the bindings are special. So you detach the bindings and you put them on each ski that it becomes, and it's loose in the back, so you can walk like this, and then
Right.
you walk up like touring skis. It becomes touring skis
Right, right,
essentially.
right.
Yeah.
And so you are going uphill on them like touring skis, and
Mhm.
then when you're ready to ride back down, you
Yep.
turn the bindings, and then that, I guess, connects the board together so that it's a
Exactly.
rigid snowboard, and you can ride regular goofy, and then
Exactly.
head down the hill back
Exactly.
home. That sounds
Exactly.
great.
It
Yeah,
is
I'm gonna
so
check.
good.
Now I'm obsessed.
Yeah. I mean, you're Canadian, you said.
Yeah. No, I live on a ski hill.
Oh,
My
really? I mean, damn.
yeah,
Okay.
yeah.
Then there
Yeah.
you go. I
So
mean,
yeah, I live on the
easy.
flanks of a ski hill, and some years. I mean, it's a deactivated ski hill, so it was
Even better.
once.
Because then
Yeah,
you have
it was.
powder. I mean, that's what you're looking for, right? Or at least I am.
That's exactly
Yeah,
it. Yeah, you want the powder, and
exactly.
and so it is a bit of a pain to get up into it.
Hmm.
But that's typically what we'll do is sort of before the season opens, we'll take our snowboards, climb up, and it's just such a pain. You do that
Yeah.
like
But
you're
you're in
like,
your
oh yeah, I'm
30s.
gonna take the first couple of weeks before ski season opens, and we're just gonna go hit that powder. And you do one day of that, and you're like, I'm gonna wait for a ski lift now. So
Yeah.
having a way to be able to actually get up in that feels more like cross country skis. That sounds terrific.
Yeah, exactly. It does, and it is. So I mean, you zigzag up, so it's not like just uphill, and it's great. And I've been exploring more of the Scandinavian North now too. So it's more like it's the Arctic alpine environment. It's just amazing. And being from Sweden, I should been exploring more of that than I have. So it's gonna be my
Yeah.
winter activities from now on.
Yeah. It's funny for me, my sort of access into the forest. Typically, I wait for it to get snow free, and then all the hiking trails open up, and then we're out in it.
Mm.
But I would love to sort of think about ways to get out into that when there's tons of snow.
Yeah,
And
exactly. Because like
you
that's
know,
what it becomes. It's not just descent. It's not only about the descent. It's also about the whole adventure that you have when you're climbing up. You're
yeah,
far away from the like lift system, and you're just climbing up some mountain somewhere, and everything is amazing and beautiful. And it's so silent, and you just have you and your friends in nature
yeah,
and avalanches.
yeah. Yes,
Yeah.
yeah. We're not too bad for. We've got a couple of places to get avalanches. It's not that
Mm.
bad here. Our mountains aren't that high, on Vancouver Island. But no, that all sounds great. Well, Tor, thank you so much for taking the time to chat. I look
Yeah,
forward
anytime.
to having a meal with you on the moon sometime.
Oh, certainly. I'll send you an invitation directly
Yeah, all right, that sounds
if
great.
I
All
will
right,
have a
good
go.
luck.
Oh, yeah,
Good
thanks.
luck with your work. I hope you enjoyed this interview with Tor Blomqvist. I'm going to give you some final thoughts, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bodu, Carradine, Chuck Hawkins, Commander Bailock, Dark Finga, David Gilton, and David Matz, Enthraller Reading and Math for Toddlers, Eric Lindstrom, Evan.Pro, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Switz, Michael Purcell, Nordspace, OneStepForAnimals.org. Please follow my nephew at vbrick6994, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Funlamunley, Team 49, Telescopes Canada, Vlad Chiplin, Wolfgang Klotz, and Zelda Ward Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So I hope you enjoyed this conversation with Tor. I have these moments where I am reading papers about, for example, the one that I mentioned in the interview that really kind of crushed me. Like, oh, you can't have a greenhouse. There's too much radiation. It'll kill all the plants. So, and in fact, you probably can't even just have a production facility in a sea container. You're going to get a lot of cosmic radiation. You're going to need to put this under a meter of regolith. Then that brings in architectural issues that, how do you find this regolith, dig it up, pile it over your container? Like, that's challenging. And yet these might be the levels that we need to get to. You're looking at the production of carbon dioxide, the microgravity. Will plants grow in 1/3 gravity, in 1/6 gravity? What are going to be the downsides of that? And so when you hear people saying, "Oh, I want to live on Mars. I want to set up a colony on Mars," there should be this part of your brain that thinks about the long list of unsolved problems that are critical to human health, that if we don't get these right, then people die. And so then there is no colony because everybody's dead, because they made a perfect breeding ground for E. coli and they all died. And so we need to solve all these problems. And if that work is not done, then that colony is not possible. These places are not ready. And so we need to have those steps taken to know that we're on the right track. And you can kind of like wake me up when somebody has grown plants on the moon. Wake me up when somebody has grown plants on Mars. That's when you can start to say, okay, we're now moving in the right direction, that some of these ideal science fiction dreams are starting to become a reality. And until then, you can kind of discount them and go, we haven't thought this through yet. Get back to you when you have. And I think that's really valuable for you to sort of manage your expectations and sort of try and balance the dream against the reality of where we stand right now. But it's all fascinating to me. I enjoy these kinds of, the gritty details, the laundry list, the to-do list, the Gantt charts, the things that need to be done to make other things possible. And this all just scratches that itch for me. All right, we'll see you next time.